Welcome to the brief technical presentation for Susumu's RG series chip resistors. This presentation focuses on the RG's outstanding tolerance to severe environmental conditions. This presentation also describes the need for resistors that can withstand severe environments with special focus on sulfur tolerance, and addresses how Susumu's RG series meets such needs. Finally, this presentation also briefly explains why the RG series chip resistors are so reliable against any harsh environment. Unlike most electronics equipment, such as computers that are used in a control environment, there are applications such as automotive, mining, outside communication devices, and industrial equipment that are exposed to severe environments. Severe environments include high temperatures, high humidity, vibration, industrial chemicals such as machine oil, and exposure to a sulfur-containing atmosphere. Sulfur is a common component of automotive exhaust gas and is highly reactive with silver, posing potential damage to resistors. Such applications require resistors that are resistant to these harsh environments. The flower of sulfur, or FOS test, is the standard industrial test that examines the porosity of the passivation materials over metal using sulfur vapor and attempts to induce a reaction with silver and other metals under passivation. Some automotive electronics companies require this test for component qualification. The example provided above requires 20 days of exposure to sulfur vapor without the formation of silver sulfide. Sulfur vapor is known to penetrate through silicone and other organic passivation. Susumu's RG series uses inorganic passivation, which is almost equivalent to a hermetic seal. Sulfur is also known to react with silver and sometimes with copper to create metal sulfides that cause resistors to drift or to become open in extreme cases. Susumu's RG series does not contain any silver or copper, hence there is no reaction with sulfur. To demonstrate Susumu's RG's tolerance to sulfur vapor, we contracted with Battelle Lab, a third-party lab, to conduct the flower of sulfur test exactly as previously described by one auto electronics maker. A direct quote from their report shown above confirmed that there was no sign of silver sulfide after 20 days of the flower of sulfur test. The silver coupon, intentionally placed to prove the test's validity, was covered with silver sulfide. We also conducted our own test exposing the RG series resistors to SO2 gas. If any of the metal in the resistive material or terminal reacted with sulfur, significant resistant drift should have occurred. As shown above, the average drift was less than 0.01%, which is negligible. Another test conducted by Susumu involved H2S gas. In this test, the samples were exposed to H2S gas until the silver indicator on the test board formed a 1 micrometer thick silver sulfide plume. The drift on the RG series resistors was again minimal. The RG series is also tolerant of high temperatures, vibration, and industrial chemicals such as machine cutting oil. This is sample data showing how the RG series is tolerant to high temperatures. Under conditions of 155 degrees centigrade, the RG series did not show any drift after 3,000 hours. The RG series resistors have an operating temperature of up to 155 degrees centigrade. The RG series did not show any drift after 100 hours of a tolerance test, which exposed the product simultaneously to a high temperature with high humidity and exposure to machine-cut oil. This demonstrates an equivalent tolerance to thick film products. The mill standard vibration test also demonstrates virtually no drift and no visible damage to the RG series resistors. Our accelerated reliability test that was equivalent to 83 billion component test hours resulted in no failures. The statistically estimated fit rate is 0.011, which is 11 parts per trillion. Virtually no failure is possible. The key to the RG series' extraordinary environmental tolerance and reliability is its inorganic passivation, which is applied using a CVD process over our resistive film. After the inorganic passivation is applied, laser trimming is executed through the translucent passivation film under sealed conditions. Normally, laser trimming creates a significant amount of dust and becomes a source of contamination. However, Susumu's RG trimming process does not produce any dust, and the resistive film is protected throughout the trimming process. Because of their inorganic passivation and protected laser trimming process, Susumu's RG thin-film chip resistors offer unprecedented tolerance to severe environments and boast unmatched reliability, including sulfur resistance. If you are searching for a chip resistor that can tolerate any severe environment, your search is over. Susumu's RG is the answer. Thank you for your interest in Susumu's chip resistor products.